Good evening. For this next video, we are going to take a look at performing independent samples t-test. So I'm going to start by sharing some data with you. And basically what I want to do is just take a minute to walk through the data with you, and then we'll talk about the independent samples test. So this is a data set from the Pallant Guide, the SPSS Survival Guide by Julie Pallant. And the data set is called sleep.save. So we are looking at various factors related to sleeping. So in the data view, you can scroll down and see that we have 270 participants, male, female, various ages, various marital statuses, various educational levels. We've got some random data filled in on some about weight and height and health rates, and smoker, non-smoker, alcohol, caffeine, that sort of thing. So basically, what we can gather from this was that this was a pretty in-depth survey looking at many habits of people. And this data was used to compare various lifestyles and make connections to sleep and quality of sleep and that sort of thing. So if we click on the variable view, we can look at our data sets and see that actually 55 different qualities were measured, or 55 different characteristics from ID, sex, and age, all the way to if people stopped breathing, or they were restlessness, or if they felt lethargy or fatigued, or and that sort of thing. We're looking at numeric data like all SPSS variable views. You can see the width of the columns, the number of decimals. We can expand a little bit here on this column so you get a wider view of labels. So this gives us a little bit more idea of what specifically they were measuring with this data line. And then you can see various values assigned, levels of measurement. So what we wanted to focus on for this video was independent sample t-test. In this video journal, we'll explain how to perform an independent samples t-test. We are using this test to compare the mean scores for two different groups. Our question is there a significant difference in the mean sleepiness scores for males and females? So those are our two different groups. We're using the sleep study survey data. That's the data that I just went over with you. Our independent variables are going to be the male and female participants, and our dependent variables is the mean sleepiness scores. There are 5 assumptions that we're going to need to check. Is the dependent variable measured at interval or ratio level on a continuous scale? Yes. Is the sample chosen randomly? Yes, it was chosen at random and given at random. Is there or are there independence of observations? Yes, they're not dependent upon each other. They're separate observations. Is the distribution normal? We can run some descriptive statistics to check for a bell curve shape and look at the histogram, but since we have more than 30 in our sample, even if we had a violation, it shouldn't cause serious issues. So we won't take the time to do that in this video. The fifth assumption we will check out later is the homogeneity of variance, and we will run the Levene's test for equality of variances. So in pulling up this SPSS data screen, we're going to go to Analyze. And we're going to go to Compare Means and Proportions. And doing some research, this is SPSS version 29.0, which is the newest version on the market. But versions 28 and some previous before that, in this line item, it's just compare means. But here, it's compare means and proportions. So anyhow, we're going to compare means in an independent samples t-test. So we click on this. And then like before, we will go through these different variables. And we're going to move dependent variables under the test variable box. So in this case, we were looking for a sleepiness score. And then we were looking for our groupings, which would be sex or gender, labeled 0 and 1. And we click OK on that. So and move the sex over to the grouping variable. And then we're going to click on define groups. And that allows us to assign labels to here. And we could do females are 0 and males are 1, or you could have done males 1, females 2. It doesn't really matter. It's the preference on the user. And the suggestion is to check your coding because your coding dictates what you're going to put here. To be able to get accurate statistics, however you coded your original survey is how you need to code your grouping variable. So you can go to the code book or you can right click on the variable and go to define groups and it'll actually bring up the information. Anyhow, once we click OK, a screen of data is going to pull up. So what I'm going to do is pull up the screen of data that I had previously produced. And next we're going to scan the data looking for accuracy. For instance, the added N of males and added N of females, when we add them up, we're 20 short compared to the total number of participants. We look back at the responses and see that 20 are missing input. That said, the number is actually correct. We just had 20 people not give some sort of response. Next, we'll check our fifth assumption, and that's Levene's test for equality of variances, and that's in the second chart here. Right here. Levene's test. We're going to look in the significance column. And if our significance number is larger than 0.05, then we can assume the variances are equal. And we will use the top row of information. 0.476 is larger than 0.05. So in this case, our variances are going to be assumed to be equal. If it was less than 0.05, your equal variances are not assumed, and you would use the second row of data or information in the chart. This does not violate the assumption, so all 5 of our assumptions are okay, and we can proceed. If you need to use a t-value, you would use the t-value in the top row, which is 3.196. And now that we've checked assumptions, the next thing to do is to check the differences between the groups. We're going to look over here in the significance of the two-tailed. So we're going to focus right here. We're using the top row. So we're looking at 0.002. If our number is less than 0.05, there is a significant difference in the mean scores. If it's greater than 0.05, there is not a significant difference in the means. And of course, our score of 0.002 is less than 0.05. So yes, there is a significant difference in the mean scores of sleepiness scores between males and females. Moving to the bottom chart, we're gonna check the effect size using Cohen's d-test, and 0.408 is in between a small and medium effect size, but closer to a medium. But there is a small to medium effect size. So in an independent samples t-test that was conducted to compare the sleepiness scores for males and females, there is a significant difference in scores for males and females. The magnitude of the difference in the means was median in size. Thank you for joining my video. And next time, we're going to take a look at ANOVAs.